So today we're going to talk about ratios and proportions, and these are the 7-1 notes that will be listed on the lesson plan. So what I've done at the top of these notes is list what a ratio, a rate, and a proportion is in reference to. Guys, a ratio compares two numbers of the same measure. So you may see it written three different ways: A to B, or A to B. Those are three different ways that you may see a ratio written. A rate compares two different quantities of different measures. So think rate of speed to time in which it would take you to arrive. Okay, those are two different measures, two quantities of different measures. Proportions is just taking two ratios. So here we have A to B, which is equal to C to D. The two inside terms refer to the mean, and the two outside terms would be the extremes. All right, we won't dive too much into these over the next couple of units, but I just wanted to introduce them to you. Here, given the first ratio, is asking you to find x. So we have a ratio of 3 to 4 to 5, and then we have a ratio of 6 to 4x to 7x minus 4. So you may see them written like this, or I have rewritten them like such. So your first two terms, 3 to 6. And then I set up the next two terms, equals a 4 to 4x. And guys, from there you just cross multiply to get 12x is equal to 24. Divide both sides by 12 and we get x is 2. Now all of the examples given in 7-1 are set up accordingly. So that's why I'm just going to go through the notes with you versus working them out by hand. Here, again, another ratio, but this time we're asked to find the x and the y. So I took my first term, 4 to 12. To find my x, I'm going to set it up 5 to 6x plus 3, and then cross multiply. Then I'm going to do the same thing again, 4 to 12, but now this time I'm going to use my last two terms. 6 is proportionate to 4y plus 2. When you cross multiply, make sure that you multiply both terms, 4 times 4y and 4 times 2. That is the most common mistake that students will make when coming to ratios. Now guys, examples 3, 4, 5, and 6 do the exact same thing as we have done right here. Just simply cross multiply and solve for your variable. I do want to show you example 4 because when you cross multiply here, you're multiplying two binomials. So be very careful. We're using the full method. X times x times negative 4. Negative 4 times x, negative 4 times negative 4. Now guys, this is a quadratic. So anytime you're using you have a quadratic, you want to use your zero product property, which means you move everything over to one side, setting your equation equal to 0, and then factor. So these two are worked the exact same way. Example 4 and example 6. Example 8 talks about 4 sides of a quadrilateral are in a ratio of 2 to 4 to 5 to 7, and that the perimeter is 36. What is the shortest side? So what I want to point out right here is, guys, this talks about a ratio. This is not saying that the sides are 2, 4, 5, and 7, but that their ratio is 2, 4, 5, 7. So to get the side, we're going to multiply 2 by something to get the side. We're going to multiply 4 by something to get the side. So on for 5 and for 7. But we know all the way around that quadrilateral has a perimeter of 36. So whatever we multiply these guys by, they're not going to be larger than 36. So if I combined all of my like terms, I get 18x. Divide both sides by 18, and I get x is 2. So in this one, it's asking you for the shortest side. 2 times 2 gave me 4. 4 times 2, 5 times 2, 7 times 2. These are the lengths of the sides. So therefore, the shortest side would be 4. Same thing with number 9. 3 angles in a triangle have a ratio of 5, 12, and 19. 5, 12, 19. Again, those are not the angle measures, those are the ratios. But what do we know about the angles of a triangle? They all equal 180. So 5 times something, plus 12 times something, plus 19 times something will equal 180 because we know those angles cannot add to be anything greater than 180. Combine like terms, divide both sides by 36, and we get x is 5. Now it's asking us find the ratio of the triangles. So 5 times 5, 12 times 5, and then 19 times 5. So 25 to 60 to 95. Now let's look at the last one. The ratio of girls to boys is 7 to 5. So if I have 192 students, how many of them are girls? Okay, now this is what most students will do right here. They will put the 7 over 5 is equal to x over 192. But let me show you the problem with that. Guys, you're comparing girls to boys on this side, but on this side you're comparing girls to students. Guys, students includes both girls and boys. So tell yourself that. It includes girls and boys. So this is not a fair comparison. This 5 only represents the boys, where the 192 represents the entire student body. So if we're talking about a ratio of 7 to 5, we're only talking about a total of 12 students. And now how many of those students are girls? 7, because it says girls to boys, so girls to boys. 7 of those 12 students are girls. And how many girls represent the entire student body of 192? So I wanted to show this because if you do cross multiplication right there, you get 268.8. You can see that that is a far difference from what we get right here. So guys, cross multiply, divide by 12, and for 192 students, 112 of them are girls.